All right, we're going to continue with section 10.4, just looking at standard deviation and variance. So we just finished talking about the medians and how to spread data out around the medians. Now we want to talk about spreading data out around the mean. So we're going to take a look at standard deviation. So you may have heard that term before. It basically means how it deviates from the mean, how it spreads out from the mean. Okay, so let's take a look at this. Standard deviation, think of the data points spread from the mean this time. Last time it was from the medians. Okay. A low standard deviation a low standard deviation means that the points are close to the mean. I should say indicates, then I don't have the same wording here twice. And then, of course, conversely, a high standard deviation or a large standard deviation indicates that the points are farther away from the mean. Okay, so I'll let you write that down. A high standard deviation or a large standard deviation means that the data points are farther from the mean. So standard deviation, the formula for standard deviation is quite simple until we break it down. So first of all, the symbol for standard deviation is the lowercase rho. So oftentimes you'll see rho, or you'll see this as standard deviation, okay, is, here I'll write the word too. Well, it's very simple. It's the square root of what's called the variance. Well, that's simple if we know what the variance is, okay? So the variance is done by calculating, and this is a long process. Make sure your calculator battery is good to go. You're going to need a calculator. You're going to need something to write down with because it does take time. It's tedious. Not difficult, but tedious. So given some data points, all right? And again, we mentioned them before as like x sub 1, x sub 2 for the second data point, x sub 3 for the third data point. Depends on how many data points we all have. We're just going to have some number of data points. To find the variance is found by taking each individual data point and subtracting the mean, and then squaring it. Then take the next data point, subtract the mean, and square that. And you keep going for each individual data point until you get down to the last data point, subtract the mean, square that. Once you find all those individual numbers, then we divide by the total number of data points. Okay? So it takes a little bit of time. All right, so what we're going to do is we'll take a look at example 8 that I gave you on those printed examples, and we'll practice this skill. So the example 8 that I gave you just says that for the distribution below, we want to find the mean, because we need the mean. Here, I'll even remind you that that's x bar, find the mean. Then we need to find the variance so that we can find the standard deviation. Then we'll construct a normal bell curve, okay? So for the distribution, and I didn't didn't do very many points because now it's not about finding the mean. It's about calculating standard deviation and looking at what that looks like on a normal curve. All right, so here are the numbers. Again, I already ranked them for you. So the numbers are 42, 46, 50, 50, 52, 54, and 56. Okay, well, let's first calculate the mean. Also known as X bar. Well, we know to find the mean, we take and add up each data point and divide by the number. See, we have some sunlight coming in. Let me close the curtain. Close our blinds in here. Let's see if this helps. All right. I think I got rid of that bright spot there. So let's calculate the mean. You're probably finished by now. So 42 plus 46 divided by the total number, 1, 2, 3, 4, 5, 6, 7. I got the mean to be 50. Now, we want to calculate the variance. So the variance is very tedious, but I'm going to write it out so that you can see how we get each one. We need to take each individual data point, subtract the mean, and square it. So our variance would be found by taking our first data point, 42, subtract the mean, and square it. 46, subtract the mean, and square that. Well, what's nice about 50, when I subtract the mean, 50 minus itself, but I'm going to be literal on this first example. If I take each data point, 52, and I'm going to go right on off the screen here because I think you have the idea. If I keep it just doing that with each and every single point, so keep going. Then divide by the number of scores we have. So if I've done that with each of the 7 data points, divide by 7. When I calculated this earlier, I got a variance of 19.4287, etc., etc., etc. Right? It goes on forever and ever and ever. The further you go out, I'll probably ask for like the 10th place, but the further you go out, the more accurate it's going to be. And then to find the standard deviation, okay, our standard deviation, now if you want to call it standard deviation, that's fine. It's always the square root of the variance. Well, from algebra, taking a square root is the same as raising something to the 1/2 power. So I could take, it's already in the calculator, I could take all of this and raise it to the 1/2 or the 0.5 power. That would give you the standard deviation, that would give you the square root. Or I, of course, could write this out. And again, the more digits you put in here, the more accurate your answer is going to be. Okay, so again, I could take the variance, raise it to the 1/2 power. That's the same as taking a square root. And when I did this, I got about 4.4. So I got the standard deviation, which this author calls S, to be 4.4. So what that means is now we want to do a normal bell curve. And this is how nice a normal bell curve is. Okay? A normal bell curve, we've probably all seen them with grade distributions. I need these numbers over here. I only need the standard deviation. So a normal bell curve, looks like that sunlight's coming in again. Let me pause this and go close the blind. Okay, so the normal curve looks like the following. It'll be a nice sloped curve that looks absolutely identical from the middle value. Okay, so it should look like it reflects around the middle. This is a normal curve. Now remember, standard deviation and normal curves have everything to do and are all about everything around the mean. So what we first want to do is in the very middle of our curve, if we can estimate and find the exact center here, okay, that exact center is where we want to place our mean. And then the way a normal curve works is, what we do from there is we go to the right, 1, 2, and pretty much everything fits within 3 standard deviations. So this is going to be the mean plus 1 standard deviation. Then the next one will be the mean plus 2 standard deviations. And then the third one is the mean plus 3 standard deviations. And we're going to do the same thing on the other side. We always start from that middle value. We always start from, think of this as being the very middle of the graph, that mean, that average. And then if I go about the same the other direction, 1, 2, 3, I'm going to take the mean. Here, I'm going to move this down. And I'm going to take the mean and I'm going to subtract 1 standard deviation, take the mean, subtract 2 standard deviations, take the mean, subtract 3 standard deviations. So for our curve, for this data, for this example that we just had over here, I'm going to do my normal bell curve. Sometimes that's the hardest part on the drawing. Mine's not very tall this time. Probably should have done a better one here. That's a little better. Okay? So for my normal curve here, my normal distribution, first thing I have to find is the mean. Well, we did that. So this very middle value right here is our mean. Our mean was 50. And then I'm going to go 3 standard deviations to the right, 3 standard deviations to the left. 1, 2, 3 to the right, 1, 2, 3 to the left. So if I take 50 and add my standard deviation, this next line will be 54.4. I'm going to make this smaller. I'm having a rough time today. Not my smoothest lecture. So here's 50. Here's with 1 standard deviation, 54.4, because remember our standard deviation was 4.4. Now I'm going to add 54.4 again. That's the same as adding 2 standard deviations. So that gives me 58.8. Then I'm going to add another standard deviation, which should give me 63.2. Same thing the other way. I'm going to subtract 1 standard deviation, so that gives me 45.6, because that's 50 minus 4.4. Then I'm going to subtract 4.4 again. That gives me 41.2. And then I'm going to subtract 4.4 yet again the third time. Okay? And so it's a pretty good rule of thumb that you want all your scores within 2 standard deviations from the mean. And so sometimes you'll see you'll see whenever they have these, sometimes you'll see these broken up into little wedges. Here's one standard deviation away. Here's a second standard deviation away. Here's a third standard deviation away from the mean. Here's one standard deviation, two standard deviations, three standard deviations. And the empirical rule says that within two standard deviations, we should have 95% of our data. Okay, but that's how you create a bell curve. All right. Okay. So that's pretty much it. We can look at another one. Now let's take a look at another example here. This is the last example, number 10. All right, so I'm going to pause this while we write it down so that we can take a look at how to interpret a normal curve. All right, so let's take a look at this. Let's go ahead and, on the exam, I know I probably already read this, but I had to pause. We know that the mean is 79. So I'm going to go ahead and draw a curve just for the visual who like to have kind of an idea of how to figure this out logically or with a picture. It's a little crooked, but I know y'all are forgiving. So the idea here is our mean is right here at 79. And according to this, anybody who got at least two standard deviations above the mean. So one standard deviation, two standard deviations. So I'll call this one standard deviation, call this two standard deviations. Anybody who gets at least two above will get an A. So what's the lowest grade they could get and still get an A? Well, if the standard deviation is 5.5, and this is 79 plus 5.5, so this is 84.5. And then if I add a second standard deviation, so I left off with 84.5, and I add 5.5, that gives us a score of 90. And then we need to kind of look for and make sure that we annotate, because it says at least two standard deviations. So that means we need at least a 90. So we need a score of at least 90, so that would be greater than or equal to a 90% in order to get the A. So there it is. All right. So that gives you kind of an overview of the various measures of central tendency and measures of variance. And there we have it. So until next time, have a great day.